In this lesson, we're going to be talking about piecewise functions. And piecewise functions are just functions that are represented using multiple equations instead of just one equation. So the first thing I want to start with is looking at a good real-life example. Here we've got an intramural sports league. And to join the intramural sports league, it's $180 per team, and that includes up to the first 5 members. So if you have 1 to 5 members, your cost is going to be $180 no matter how many people that you have. So if you have 1 person, the cost is going to be $180. If you have 2 people, it's still going to be $180. 3 people, still $180, 4, and 5. But then it says here, for each additional team member, there is an extra $30 fee. So for each one of those people that we add, it's going to be another $30. So for 6 people, it's $180. That included the first 5 plus $30. So that's going to be $210. If we have 7 people, we have the $180 plus that $30 fee twice. So that would be $240. If we have 8 people, we'd obviously have to pay that $30 fee 3 times, which is $90. Added to the $180 would be $270. A piecewise function can be used to represent the situation because we have one equation that can work for this group of people right here. But then we need a second equation used to represent these people. So how does that work? The way we write a piecewise function is we set C, and we're going to do C of P, the cost depending on the number of people, is equal to. And then instead of just writing one singular equation, we're going to write a bracket so that we can write 2 equations. We know that the cost is $180 for the first 5 people, and then for everyone after that, it's $180 plus $30 per person. Now, once we've written this, we want to be sure that the person reading it knows when to use the top equation and when to use the bottom equation. So out to the side, we write, we use the 180 if the number of people is greater than or equal to 1 and less than or equal to 5. We use the second equation only if the number of people is greater than 5. And that's a piecewise function. It's just a function that's broken up into multiple parts based on different things that are going on. If you've ever tried to order something custom, like shirts or t-shirts for a party or something, you may have seen a situation like this. The more shirts you order, the cheaper per shirt the price becomes. But no matter how many you order, you have to generally pay some sort of setup fee. Usually that's for the printing, maybe it's for the shipping, it's whatever. But here it's a $20 processing fee on every order. So you'll see each one of these equations has a plus 20 no matter how many shirts you buy. The first setup is if you order 0 to 24 shirts, it's $17 a shirt. So you'll see that in this top equation, $17 per shirt plus $20 if the number of shirts is between 0 and 25. Then, if you order 25 to 49 shirts, you're going to pay $15.80 per shirt plus the $20, and that's only if the number of shirts you're ordering is between 25 and 50. And then last, your cheapest bet is if you're going to order 50 or more, then it's going to be $14 a shirt plus the $20 setup fee if you're ordering 50 or more shirts. Then if you want to determine how much it's going to cost you, what if you want to order 26 shirts? Then you're going to decide which one of those, and it looks like 26 falls in the green. It's more than 25 and less than 50. So we'll use the cost of 26 shirts is equal to $15.80 times 26 plus 20. And we can calculate that and figure out what the cost would be. If we only want to order 10 shirts, then we're going to have to use that top yellow equation because 10 is in between 0 and 25. So the cost of ordering 10 shirts would be $17 times the 10 shirts plus the $20 setup fee. And that can be calculated to give us the total cost of ordering those shirts. And you can determine how many shirts you need and what is the best deal for you. This is called evaluating a piecewise function. You're given a number and you decide which one of those equations you need to use. We have two equations here. We have 3x minus 1 when your x values are less than or equal to 1. And then we have y minus 2x when your x values are greater than 1. So if I want to find f of 3, then I see that my x has a value of 3. And since 3 is greater than 1, I'm going to use this bottom equation. So I'm going to say 1 minus 2x is the equation I need. And I'm going to plug in that 3 for x. So I get 1 minus 2 times 3, so 1 minus 6. And the value of f of 3 is equal to negative 5. Now what if I want to find f of negative 5? Now negative 5 is my x, and I see that negative 5 is definitely less than or equal to 1, so I want to use that yellow equation of 3x minus 1. So I'm going to plug in negative 5 for my x, so 3 times negative 5 minus 1. So negative 15 minus 1 is negative 16. And that's how we evaluate a piecewise function. I'll put the graphing of piecewise functions into the next video.